Good morning, all of you. So let's start today's class. Today we will learn cutting off mirror. Cutting off mirror. So first I am taking one mirror, concave mirror. You can see here, this is a concave mirror. This is pole of mirror. Here is focus. And let us suppose here is center of curvature. Now see here, this object I am keeping here between center of curvature and focus. O indicates object. So here you are getting image beyond center of curvature. So this is what I. I is image. Keep it in mind. O is what? Object. And I is what? Its image. Now what I am doing? I am cutting this mirror. Now this is a initial situation. Object is between C and F. I is image and it is beyond C. Now I am cutting. So this mirror I have cut and I have arranged these two pieces like this. after cutting. So this principal axis I am drawing with the dotted lines. And this is what your original pole. What is this? Original pole. And on this only you are having object also here. This is what, suppose object O. But this is what cutting finished. After cutting we have placed like this two parts which are perpendicular to the principal axis. What we did? Perpendicular to the principal axis. Next, now what to do? Number one, two parts separated perpendicular. Number one, two parts separated perpendicular. Then how is this? Let's see. If you will understand this diagram, then everything is very easy. Now these two parts we have placed like this after cutting. Okay. And now object is where? Obviously object is here. Object is here only. And this distance is how much? U. What is the distance? U. Enough. From this pole to O. That is what your object. Now this is another principal axis for this mirror now. Which I am denoting with dot dot lines. Or else even you can keep this as a actual line and this original line we will denote as a dotted one. Now let us suppose from this principal axis this distance is y1 and this distance is y2. Okay, means these two parts we have separated and placed like that. What is the distance? Y1 and this one is y2. It means what these two pieces we have placed like this y1 and y2 perpendicular to the principal axis. Now for this you are getting image, for this piece you are getting image somewhere here. This is image I1 and for this piece you are getting image I2 because this is P1 suppose and this one is P2. And this O is what? Object. Object for both the parts. Object for both parts. P1 is part 1, P2 is part 2, you can say. Now this I2 is how much? See here. This I2 is equal to, can I write like this? M2 into Y2. And this distance is how much? Phi. What is this distance? Phi. Even for this also, this image distance is how much? Phi only from this image, from this mirror. And this I1 is equal to what? M1 into Y1. M1 into Y1. Now, what happened in the diagram? You see, this is a pole, this was the previous object, and just we cut this mirror and we have placed these two parts as shown in the figure. So see, for image partition from principal axis, M is equal to minus V by magnification, which is equal to what? I1 by object. Yes. O is what? Y1. O is what? Y1. So therefore this is equal to I1 by Y1 and therefore this I1 is equal to M times Y1. M times Y1. Next. Now separation distance between two images. Separation distance between two images. You see, from this point to this point, we have to find the distance. So what is this? This plus this m1 y1. Yes or no? This distance is there, no? Can you see? This one m1 y1 is there, no? So total distance you have to just add. So this m1 y1 plus this y1 plus this y2 plus this is your total separation distance, that is equal to m1 y1 plus m2 y2 plus y1 and plus y2. This is what separation distance between two images. If suppose if m1 is equal to m2 is equal to m, if m1 is equal to m2 is equal to m, then what we will get? Separation distance d is equal to my1 plus my2 plus y1 plus y2, right? And if we will take m common from this, m into y1 plus y2 plus y1 plus y2, and if we will take from this both y1 plus y2 common, then what we are getting? Y1 plus y2 into bracket m plus 1. This is what your separating distance when we have placed these cutting parts like this. Isn't it right? It is very simple. Note down. Okay. Now next part. Second one. Now how we have cut? We cut along the principal axis and place perpendicular. Now how I am placing separated parallel. Okay, two parts separated parallel. Then how? Now how to keep these two parts separated for this object? So initially you are having mirror like this. We have placed. You can see here. And here it is focus, here it is center of curvature, and object is placed in between this, and now here it is u distance. Okay, now what is the case? Two parts separated parallel. So what to do? You can see here after cutting what happens. So here again I am taking the mirror and I am placing parallel. Hai na? How I am placing parallel. So here is the first mirror, suppose, and I have placed another piece of mirror like this here after cutting. So see how it is. Very simple actually. This is first piece which I have placed, right? and this is another piece. Like this. And now where is object? Here is object, right? This is O, and now this is your U distance, object distance for this piece, and this another part which we have placed, that is suppose D distance apart. Then this, for this mirror, your object distance will be what? U plus D, and so from this you can find out anything whatever you want. So this is your U for this part, and this is your U for this part, and whatever the images are getting formed, you can calculate by using the mirror formula in such type of cases. Understood? So when these parallel mirrors we are placing, then object distance is going to change. Whereas if we are placing here like this, then object distance is going to be same. Yes, U only for both the mirrors, but just image distance or the separation between the two images is going to change. So from this also, whatever you are getting V and V1 and V2, you find out and just do it yourself. Okay, whenever they are asking problem, right? So note down this. Yes, note down. Okay, finished. So let's move ahead and the new topic that is very important, measurement of refractive index of a liquid by concave mirror. So how to measure the refractive index of a liquid using concave mirror? This is what we are going to learn in this topic. So for that, what to do? See, first we have to take a concave mirror, something like this. Okay. like this convex mirror, concave mirror we have to take, and we have to keep like this. And now this is its principal axis, vertical principal axis. Okay, now first what to do, as this is a mirror, you take a pin. What you have to do, take a needle pin. Suppose here I have taken a needle pin. Suppose here I have taken a needle pin like this. And then as this is a center of curvature, yes or not, this is the C1, suppose this is the center of curvature for this mirror. Then if you know object is at center of curvature, where its image is forming at center of curvature, so you are getting image also somewhere here only. There is no water. Okay, is there water? No water. So you are getting image also here only. Next, now what to do, you have to pour some water. Now I have poured some water in this concave mirror. What I did, poured some water. So what happened, this slowly I will come down. So here I came now, and I got image of this needle pin somewhere here, okay, which is going to be coincide. And let us suppose this is what your C2. What is this? C2. This position is what? Let us suppose C2 after pouring the water. So now this center of curvature is C2 here. Now what I am doing, first I got this ray, and then because of this water which I have poured here in this concave mirror, the ray will go like this. This I am showing with dotted lines. Now this angle is how much? This angle is I1. Or just to keep I, this angle is I. Okay. And if I am plotting one, or I am drawing one normal here, see exactly at this point, this is the normal N, and this ray is coming like this, and after pouring water it is going like this. So this is I, means this is also hot I only, this angle is also hot I, right? This normal also I am drawing with dotted lines. Okay, can you see now? Right, this is I, this is I. Now after this angle is what? Angle of refraction, R, because this angle is what? R only, angle of refraction. from this water surface. Let us suppose this point is A, this point is B, okay, and this is what your water level. This is C1 and this is C2. Okay, understood what I did? I am writing here 2 lines so that you will understand properly what we did. C1 is the position of the pin when its image coincides itself without water. Next line, what is the C2 here? C2 is the position of pin when its image coincides itself, you know, with water. So this is same like if suppose see coin is there, no coin you are pouring in the glass, and after water when you are pouring the glass, how the position is changing, same thing is happening here also. Now in triangle ODC1, from triangle ODC1 you can see O, where is O? This point is O. Okay, ODC1. In this triangle, sine of I is equal to what? Opposite by hypotenuse. So what is that? OD by OC1. OD by OC1. Next, sine of R. Sine R. Sine R is equal to what? OD by OC2. OC2. Here I am writing another triangle also from triangle ODC1 and ODC2. These two triangles we have considered. Keep it in mind. This triangle and this triangle. So we got this. Now, from Snell's law. From Snell's law, mu1 sine of I is equal to mu2 sine of R. Mu1 is what? This liquid, because this is mu1. Understand? Mu1 and this one is mu2 for air. Mu1 is for liquid, so therefore I am keeping as a mu only. Sine of I is equal to sine of R, because mu2 is equal to 1 for air. Understand? So you got this mu sine I is equal to sine R. Next, what we got? Mu sine of I is equal to sine of R. What is the sine I value? OD by OC1, and sine R value OD by OC2. So mu into OD by OC1 is equal to OD by OC2, right? So this OD and this OD will get cancelled. Mu is equal to OC1 by OC2. Okay, this is what we got, one formula, OC1 by OC2. Next one, C, taking paraxial ray assumption, taking paraxial rays assumption, OC1 is nearly equal to DC1 and OC2 is nearly equal to DC2, then you are getting mu is equal to DC1 by DC2. So just a depth, whatever the depths you are having, if you are taking that ratio DC1 by DC2, you will get the refractive index of that liquid. Understand? And if we are neglecting depth of liquid, if liquid is very what we can say, we have poured very small layer of this liquid, then neglecting depth of liquid, what we are getting, neglecting depth of liquid, then what we are getting, mu is equal to AC1 by AC2, right? This is what we got formulas for refractive index. Is that clear? Understood? Okay, so let's stop here. Bye for today.